In the last video, I gave a little bit of a hand-wavy explanation about why S waves don't travel in liquid or air. And what I want to do in this video is give you a little bit more intuitive understanding of that and really go down to the molecular level. So let's draw a solid. And it has nice covalent bonds, strong bonds between the different molecules. And the bonds are drawn by these lines in between. So if I were to hit this solid, I have this really small hammer where I just hit it at a molecular level. But if I were to hit these molecules, hard enough that they move, but not so hard enough that it breaks the bonds, then essentially what it's going to look like is this kind of row of molecules are going to move to the left. So you're going to have that row of molecules moving to the left. And then the row above it won't fully move to the left just yet, but it will start to get pulled. So let me just draw all of the bonds. I'm just drawing all of the same bonds. Because these are strong bonds that we have in a solid, because these are strong bonds, actually they could be ionic bonds as well. Because they are strong bonds that we have in this solid, they'll essentially be pulled. They'll be pulled in the direction, the top row will be pulled in the direction of the bottom row. And then the bottom row, and so they'll start kind of moving in that direction. And then the bottom row will essentially recoil back. And then you fast forward a little bit. And so then the top row will have moved to the left. The top row will have moved to the left. And now the bottom row will start to move back. And then the bottom row will start to kind of move back. Especially because, remember, it's bonded to other things down here. It's bonded to more of the solid down here. So it'll move back. And you can see this transverse wave. You can see this S wave propagating. Essentially right over here, the S wave, the kind of peak of the S wave is here. Now it has moved up. Now let's think about the exact same situation with the liquids. In liquids, you don't have these strong ionic or covalent bonds between the different molecules. You just have these weak kind of bonds, usually formed due to polarity. So in a liquid, water is a good example. You just have these kind of weaker bonds formed because water is a polar molecule. So the kind of halfway polar sides or the halfway positive sides are somewhat attracted to the halfway negative sides. So they kind of flow past each other. But if I were to hit these water molecules right here with my hammer, what would happen? Well, they're going to start moving to the left. And they're actually, this one's going to bump into that one, which is going to bump into that one, which is going to bump into that one. And they're going to move to the left. So they're going to move to the left. But these molecules aren't going to move with them. It's essentially going to, you could view it as going to break that very weak bond due to polarity. They're going to move away from each other. They're essentially, let me draw these top molecules in green. They're essentially just going to flow past each other. They're going to flow past each other. And this guy might have had also weak bonds with stuff below it too. I should draw just dotted lines. With stuff below it too. But because of the impact here, these guys are just going to flow. They're actually going to compress in this direction. You're going to have a P wave, a compression wave, go in this direction, where this one bumps into that one and then goes back, and then this one bumps into that one and goes back, and then this one bumps into that one. But the bonds aren't strong enough. The bonds, and it's even more the case with air, but the bonds aren't strong enough for these blue guys to take these green guys for a ride. And the bonds are also not strong enough for the adjacent molecules to kind of help these blue guys to retract to their original position. So when I talked about the elasticity in the last video, that's what I was talking about. The bonds aren't strong enough to cause the things that are deformed to kind of move back to where they were. And also their bonds aren't strong enough to allow the things that are deformed to pull other things with it. And so that's why, in general, S waves don't travel. They only travel in solid, and they won't travel in liquid or air.